You know, it's funny, you'd think the biggest secrets of the universe would be hiding out in some giant galaxy or a massive black hole, but sometimes they're found in the tiniest, most ordinary things. Today, we're basically becoming cosmic detectives because we're going to investigate a single microscopic speck of dust that blew a 4.5 billion-year-old mystery wide open. So, this is really the heart of it, right? What can one little speck of dust actually tell us about how the planets were born? I mean, it sounds kind of impossible, but for decades, scientists had this hunch, this belief, that if they could just find the right piece of dust and look at it in just the right way, it would be like finding a time capsule from the very beginning of our solar system. All right, so where does an investigation like this even begin? Well, it starts with the main subject. These mysterious, elusive little particles of space dust. Okay, so what we're talking about here are interplanetary dust particles, or IDPs for short. And these are exactly what they sound like. Tiny, microscopic specks. And get this, they're collected by high-flying aircraft way up in our own stratosphere. For the longest time, the theory was that these weren't from Earth, but were actual leftovers from when the planets were just starting to get built. But, you know, a theory is just a theory. In science, you need proof. So back in the early 80s, researchers were stuck on these huge questions. Were these little particles really from space? If so, how long had they been out there floating around? And here's the big one. Did they just burn up completely when they hit our atmosphere? Or could their ancient secrets have somehow survived that fiery plunge? Honestly, the answers were just not there. To crack this case, scientists knew they needed a very specific kind of clue, a kind of fingerprint left behind by the sun itself, and so began this incredible hunt for what you could almost call solar scars. And this was the clue they were looking for: nuclear tracks. The absolute best way to picture these is as a cosmic sunburn. Seriously. As a tiny particle is just drifting through space, it's constantly getting blasted by high-energy particles from the sun's flares. And these blasts literally carve microscopic tunnels, these little tracks, right into the particle's crystals. If you could find these tracks, well, that would be undeniable proof that this thing had been in space. But there was a massive problem. The common wisdom, the thing everybody assumed, was that the insane heat of hitting Earth's atmosphere would totally erase these delicate little tracks. It's a process called annealing, basically heating them up until the damage is gone. And yet, a few scientists clung to this really daring idea. They thought, what if some of the really fragile, porous particles could slow down gently enough to stay, well, cool? Maybe, just maybe, the evidence could actually survive. For years, every single search turned up absolutely nothing. The tracks were like a ghost. They were there in theory, but no one could find them. It really seemed like the doubters were right. But then, in 1984, one team decided to give it another shot. This time with a more powerful microscope and a whole new approach. And what they found? Well, it changed everything. They captured the smoking gun, the one piece of evidence that just blew the whole case wide open.
This is it. I mean, that quote from the scientific paper, that's like the dramatic courtroom reveal in a movie. And if you look, you can actually see them. Those faint, straight little lines etched inside the crystal. Those are the solar scars. Those are the nuclear tracks everybody had been searching for. After all that time, they finally found them.
And they didn't just find a couple. Oh no. The density was just mind-blowing. On this one tiny particle of dust, they counted up to 100 billion tracks per square centimeter. 100 billion. Let that sink in for a second. This wasn't just a light sunburn. This thing had been absolutely basking in the solar wind for a very, very long time. So, finding the tracks wasn't just the end of the story. It was really the key. It was the key that unlocked this vault of information about where this particle came from. And by doing that, the history of our entire solar system. The chemistry of the particle itself also told an incredible story. When the researchers analyzed what it was made of, its chemical makeup was a near-perfect match for the most ancient, primitive meteorites we've ever found. And the real smoking gun here was the sulfur. See, sulfur is an element that boils away really easily with heat, but this particle was packed with it. It was solid proof that it never got hot, which confirmed that daring cool entry hypothesis.
So, In the end, these solar scars solved every single mystery. First off, they were undeniable proof that this dust was absolutely from outer space. Second, that incredible track density acted like a cosmic clock, telling them it had been on a 10,000-year journey. And third, and this is the real game changer, their very existence proved the particle was a pristine time capsule. It was never overheated, meaning its ancient chemistry was perfectly preserved for us to find.
That discovery back in 1984 wasn't just about one little particle. It proved that we are surrounded, right now, by this constant, gentle rain of messengers from the distant past. And it just leaves you wondering, doesn't it? If a single speck of dust can be a 10,000-year-old message, what other incredible secrets are floating right above our heads, just waiting for us to look?